This is day 10 of Advent of Go 2023, and this challenge is called Pipe Maze. You use the hang glider to ride the hot air from Desert Island all the way up to the floating metal island. The island is surprisingly cold, and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labelled Hot Springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal. So as you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. Didn't look like any animal you've ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver colour as the ground. You make a quick sketch of all the surface pipes you can see, the puzzle input. The pipes are arranged in a two-dimensional grid of tiles. So if it's a pipe simple, it's a vertical pipe, so you can travel north and south. If it's a dash, it's a horizontal pipe, east and west. Capital L, 90-degree bend, north and east. J is north and west. 7 is south and east. F is south and east. 7 is south and west. F is east and west. 7 is south and west. F is south and east. Dot is a ground, so there's no pipe on the tile. And S is the starting position of the animal. There's a pipe on this tile, but your sketch doesn't show what shape the pipe has. Based on the acoustics of the animal scurrying, we're confident the pipe that contains the animal is one large continuous loop. For example, here is a square loop of a pipe. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. In the above diagram, the S tile is still a 90-degree F bend. You can tell because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loop. The sketch shows the same loop as above. So if we look at this one, we've got the S there, but the above pipe is an L which can't connect to it. We've got a 7 which it can't connect to, but we have a dash and a pipe symbol which we can connect to. So, and here is a sketch that contains a slightly more complex main loop. So S can connect to it, so it'll go left, or right. So it'll go right, up, right, down, down, right, down, left, down, left. Okay. Here's the same example sketch with the extra non-main pipe loops. So we've got the S, it can connect to these, connect up, but then it gets to here, there's extra pipe here which we can't actually go into, and the same for here and here. Okay, if you want to get out ahead of the animal, you should find the tile in the loop that is farthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach the starting point, regardless of which way around the loop the animal went. So in this first example, with the square loop, you can count the distance each tile in the loop from a starting point like this. So in this example, the farthest point from the start is 4 steps away. And on the more complex one, the farthest away is 8. So find the single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point farthest from the starting position? Okay, so we're going to start off with this complex one, which has extra pipes that can't actually connect to. So we'll put that in our input here. And the way that we will do this, first thing we'll do, we're going to look at the input and figure out which type of pipe it is. So we'll go across, so if it will look up and it'll say, okay, there's no pipe there, so don't ignore that. We'll look to the right and we'll see, okay, it is a J pipe that connects to west and north, and we are west of it, so we must connect to that. And then we'll look down and we'll see pipe, and it knows that we are north of it, and the pipe can connect to us from north, so that's the type of pipe it is. So first let's grab all the possible pipe types. So do pipes equals, this will be a dictionary, and we'll remove everything from it. We also don't need any of these, and these will have a list of the possible directions it can go. So pipe can go north and south, dash can go west, east, pipe can go north, east, J can go west, north, 7 can go west, south, and the F can go south and east. So we're going to first create the grid. This will be a list of lists, and firstly we will do for line in input, then it will be cell for line in, for cell in line. So let's print the grid and just make sure that works as expected. and that looks to be correct. Okay, cool. Now we'll grab starting position equals, this will be, so we now need to grab our starting position, so we'll do start x, this will equal x for x line in enumerate grid if s in line. That doesn't feel right. Actually no, we should be still doing this as list, but let me just grab index 0 and let's print start x 2, which that is, and then start y equals, it'll be basically the same thing here, y for y cell in enumerate grid start x. Now let's print start x start y. Okay, that didn't work. Out of range. Oh, did line there, so it should be if s equals cell. So that's 2 0 0 1 2 and 0. Good. Now we need to find out what the starting cell actually is. So start cell. Actually, something I'm going to do. Direction. This will be a dictionary. We'll have north, and to go north you go -1 0. To go south you go 1. To go west you go 0 -1, and to go east you go 0 1. So we'll do start cell equals s for the time being. Then we'll do for directions in direction. We'll do cell. Oh, we'll do firstly if start x plus direction. We'll do current x equals start x plus direction 0, and we will do direction 1 start y current y if current x greater than 0, greater equal to 0, and current x less than length of grid, and current y greater equal to 0 and current y less than grid length of grid 0. So if it is, okay, we need to change this. So in directions.items, and we'll do direction value, we'll change these to value, and we'll just create another one here, opposite direction equals this, so we'll just chuck it in like this, s north east west. Now what we need to do, valid directions is a list, and we need to do if direction in grid current x current y valid directions dot append. No, this should be if opposite direction. Now let's print valid directions to see if that is doing what we expect it to. Return nothing. So let's go through this. Print current x current y, and up here we'll print start x start y. See what that does. Those are looking correct. Now let's print out the grid location. Well, that's going to give an error on one of them, but we just want to see if it's working on the ones currently. So start off here. We got 7 for 2 minus 1, which it's not working because it's going like somewhere far away. Oh, that's right, I forgot to do directions here. Okay, let's clear this up a bit. Oh, okay, so if grid current equals dot continue, otherwise we do this. Object not callable. It's meant to be square brackets. Key error pipe. Print directions. Oh, it's not directions, it's meant to be pipes. So we'll put opposite direction into here. So the opposite, no, we put direction into there. No, we don't put direction into here, we put start x, and then we put start y, I think. Wait, what do I even do? Valid directions. It's a list. Current x, current y. And note that should be a list. Okay, what I should put into here is, I think the direction. What does that give us? South and east, that is correct. So now we need to go southeast, that would be an F. Does that look correct? Yes, this would be an F. So print direction for direction in directions if valid direction if nope, this is pipes for direction pipes dot items pipe direction if valid direction 0 in direction and valid directions 1 in direction. We will do grid start x start y equals pipe and break. Now let's print grid. Alright, equals pipe. And now we can see this one has F in it. Okay, so we've now got the grid all fully set up. Now what we need to do, so with the starting position, we're going to grab the directions that we can move, and then we'll go to here, which is actual direction, and we're just going to follow the path. So this will be a function which recursively runs, and we keep record of how many steps it took to get to a certain point in the grid, and then if we have another instance of it running where it's following the path, if it gets to a point where the current amount of steps to get there is greater than the value that isn't there, then it'll cease execution. Alright, in saying that, I need to set up grid. Is it considered steps as are we doing? Yep, so grid steps equals this. Now we'll just put in -1. So let's print grid steps just to make sure that has everything in it. It does, cool. So because I don't know how things are going to change in part 2, we're just going to create the function here. We'll do follow path. This will be current location, current path, and I think that should be it. So we'll grab valid directions. This will equal, we'll just change this to, and we'll do grid current location 0, then current location 1. So we've got the value in the grid. Then we need to go pipes and then this. So we've got the valid directions. So that's this. Then we'll do for direction in valid directions. We'll grab x equals directions. Actually, can we do xy like that? Direction. Curious as to what this would print. What does that do? Right, this needs to be under it. Okay, cool. So that does print what I thought it would. So that's down, and then that's right. So, okay, cool. That part. So we know that part's working. Then x will be plus equals current location 0. Then y 1. Print xy. Cool. That looks correct. Now we do if x y in current path, we continue. Then we do if grid steps x y is, what did I set that to? I set it to -1, does not equal -1, and grid steps is, okay, how should this be? And grid steps greater than length of current path. We then do current path dot append. What would this be? So we've got current path, which is this. Then we're going to the next location. So current path append loc equals xy. So we append that, and then we do grid steps x y equals length of current path. Then we do follow path loc and current path. So let's print grid steps here, and let's see if that's doing as we hope it would. Okay, it's doing absolutely nothing. So let's go to here, print this and this. Okay, so I did the wrong thing. It should be equals -1 or it's greater than. That number looks too high. For line in grid steps, print line, just so we can actually visualize it. Okay, I think it's because it might be reusing this current path. So let's do original path equals current path dot copy. Can I do that? Actually, we can do list like this. So where current path is, actually no, we can change this to new path, and then in here we do this. So then everywhere we use current path, we use new path instead. So let's see if that changes anything. It did. We've now got 8. So what we do is we run this. We have grid steps, return max cell in line for line in grid steps, I think. Actually no, this should be like this, I think. Yeah, so we've got the value we're using, and then we go from left to right. So for line and grid steps, like that. So let's see if that works as expected. It returned 8, so we will now grab our puzzle input, and hopefully we have done everything correctly. So now let's run it. For XY new path, line 65. Maximum recursion depth exceeded. Really? Let's print XY and see what that did. Maybe we should just put a continue down here or something. Huh, okay. I'm not sure why that is happening. I mean, it looks fine, I think. Let's go to here and print out the grid. Line in grid, print line. And we'll get rid of this print. I mean, it's a large grid, so it would make sense for it to take a long time to go through. Okay, so I decided to look up this error, and apparently we can override it. So we'll first import sys, then sys.set recursion limit, and we will do, just for the sake of making sure we never reach limit, length of grid times length of grid 0. Basically enforce that we do recursions through absolutely every single cell, which should never happen, but we'll just set that limit in. So let's run it and see. Apparently reached the limit. So maybe it's not working that. I mean, that looks like it's working. We'll do a ×2 here on the whole thing. So now let's see. Okay, so we've now got a number 6882 as the furthest distance it can travel. So let's see if that is the correct answer, which it is. So now on to part 2. You quickly reach the farthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. For example, with this, the above loop encloses merely 4 tiles. The 2 paths of dot in the southwest and southeast, marked I below, the middle dot tiles, marked 0 below, are not in the loop. Here is the same loop again with those regions marked. In fact, there doesn't even need to be a full tile path to the outside for the tiles to count as outside the loop. Squeezing between pipes is also allowed. Here I is still within the loop and O is still outside the loop. Wait, so what does that mean? Is this saying these are considered outside because it can go through? Full tile path to the outside for tiles to count as outside. Squeezing between pipes is also allowed. Here I is still within the loop and O is still outside the loop. Wait, what does that mean? In both of the above examples, 4 tiles are enclosed by the loop. Here's a larger example. In this larger example, 8 tiles are enclosed by the loop. Any tile that isn't part of the main loop can count as being closed by the loop. Here's another example with many bits of junk pipe lying around that aren't connected to the main loop at all. What? I don't get what that means at all. The above loop encloses merely 4 tiles. The 2 pairs of dot in the southwest and southeast, marked I below. The middle dot tiles, marked 0 below, are not in the loop. Here is the same loop again with those regions marked. So I understand why inside, I understand why these are outside. In fact, there doesn't even need to be a full tile path to the outside for tiles to count as outside the loop. Squeezing between pipes is also allowed. Okay, I get it, because the way these are set up, it goes like this. These pipes don't connect at all. So that means these ones can go through the middle of those. Okay, that definitely makes this challenge more difficult. So let's bring back the test example. Well, in this one there's none that's enclosed. So let's grab this one. So how do we do this? So I think let's grab all this, put into part 2. We're going to do basically the same thing initially. So instead of grid steps, we're going to do valid pipe. So we've got valid pipe, then follow path. What we will be doing, basically same thing as this. So valid pipe, grid steps, just do grid steps equals -1. And then valid pipe, we'll just change that to 1. Okay, so let's just make it true and false. So valid pipe, just make everything false. And then here, we will make it true. And we're going to do the same thing in here, but we are going to call it an enclosed tile. And we're going to just print for now valid pipe. Okay, well it gave false and everything. Alright, I need to do if it's false. Okay, and then we'll, for line in valid pipe, print line. So we're going to visualize it a bit better. Okay, so we've got the valid pipe. First we check to see if this location is surrounded by valid pipe. Then we need to find if it's enclosed in it. This is horrible. Okay, so I decided to leave the challenge for a bit because I didn't really have a clue how to approach it. But something I did see online is that there's a pretty simple algorithm to figure out in computer graphics to see whether like something is enclosed. So basically what you do is you go for like a point inside of it, and then you check to see how many, like let's say, walls of pipe there are blocking it from the outside. So you go to position on the inside, and then you go, let's say, just upwards, and you see how many pipes it passes through. If it passes through an odd amount of pipes, then it is actually enclosed within the inside of the pipe, or if it's an even amount of pipes, then you know that there is a way out of it. So we will do that for this, and I think what we've done so far can be useful for this, because when trying to go out, we now know which pipes actually are ones we need to look for, because it could be that like inside the pipe we go up, there's an even amount, but then as we continue going up we find a stray pipe, random one, and that would make it odd. But now, because we know it would give a false here, we can just go through and know that it's a false one. So I think we can probably do something very basic with this, where we just, let's print the grid out. Can't really see the grid too clearly, but I think we could just iterate through the whole thing, and if it's a dot, we could just go downwards, or something like that. I accidentally put that in part 2. So go to part 1, and we will start off with, so we've got follow path, just do total equals 0. Then we'll do for line in grid, for cell in line, if, actually I don't know if the idea I have does work. Then we do if cell equals dot, then actually thinking about it, it's not just go upwards, it would be like go upwards or whatever direction we decide, and it can't equal a pipe like this, pipe like that, F, L, because technically we could just go alongside it. I think, was that correct? What pattern are we looking for? Okay, I think it might need to be diagonals that we go instead of just vertical, horizontal. So it could be go diagonal, diagonal, diagonal. So I'm not sure. I feel like situations like this, where it just goes down like that, would cause issues. And then same thing horizontally. Can't really do that with diagonals. So we will do, what will we do with this? For line in grid, it should be X enumerate grid, then Y enumerate line, and then we'll do x2 equals x, y2 equals y, and for diagonal, the real question is which symbols can't it be? So we'll first do while x2 is which direction? We'll just do while x2 is less than length of line and y2 is greater than less than length of cell. Actually no, this should be grid and then this one is line. So while that's true, if do cell, C for cell, if this will equal grid x2 y2, and we'll do if C in pipes dot keys, and so which situations can there be where it can fit through like this but diagonally. I think it's 7 and J that we want to avoid. So we'll do and C not in 7J. We will do oh yeah, we need a variable for crosses equals 0. This will then be cross is plus equals 1, and when we get to the end of that, we'll do if so it has to be an odd number for it to actually be enclosed in the pipe. So if crosses modulus 2 equals 1, then we do total plus equals 1, and then at the end we'll do return 1. I have no idea if that's going to do what I expect. Let's just run it and see what it does. Oh, I forgot to increment this. x2 plus equals 1, y2 plus equals 1. Now let's run it. Okay, I don't know if taking that long is expected, so we'll just print x and y. Okay, it's getting stuck on the first one. So let's cancel this and we will go down to here and we will do 2, 2. See if it's running in here. Oh, right, I meant to... Oh. Okay, that's meant to be in here. Now do it. Oh, crosses... Wait, what? Unbound local error. Cannot assess, but it's here. Oh, it's because I spelt it wrong in there. Oh, I spelled it wrong here, I should say. Now I'll run it. Still wrong? Oh, somehow I spelled everything wrong, apparently. Okay, well, it's definitely not meant to be 1. Oh, how did I do return 1? I should return total. Okay, returned 12, which is wrong. Okay, wait, which one am I using? Okay, I'm using this. 0. Oh, okay. Wait, 0. This one here. So I went 1, 2, 3, 4. How did that happen? Oh yeah, and I forgot to... Well, it's not relevant for this. And C not in those. And valid x2 y2. Don't know, that won't change anything, I don't think. Yeah, wrong thing there. Yeah, so didn't expect it to fix that, but I didn't expect 0, 1, 2, 3. Okay, well firstly let's change this. So change grid so it runs from 1 to -1, line from 1 to -1, and we'll do x plus equals 1, y plus equals 1. Because if it's on the outside like that, it's impossible for it to be enclosed. So rerun that. Got 8. And which ones do we get? So 4, 0, 1, 2, 3, 4, 5, 6. Maybe I need to print out. We'll see. These. Print x2, y2. Okay, I need to change cell. Okay, so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And this one says, wait, how to get these different numbers? It should just be like this one. Oh, okay, I think I know. Wow. Let's just print this in general. Okay, this should be... No, that's fine. Then line. So is that right for the size of it? 9, then 11. Okay, that looks fine. So why? So 6, 7. Why is 6, 7 turning into 6, 8 and 6, 7, 9? So that one worked correctly. 6, 8. These are fine. Okay, we'll do this now, just so we can take another look. Get rid of these. You know what we'll do as well, valid equals list. Then we'll do valid dot append x2 y2. Actually, we'll use this for crosses. And then we'll just do the length of crosses. And then we can do print x, y, print crosses. Okay, each of those passed once apparently. So 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, then 1, 2, 3, 4, 5. So this one, how would I only get 1? Okay, I think there might be something wrong with the loop. It's just at the bottom here. Print, just print these two things, so we can clearly see. See, the last one it checks is 7, 8. Wait, no, 6, 7. 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. I think that's this one. Okay. Guess that one definitely doesn't work. Could be possible that I'm using the wrong symbols here. So not 7 or J. So we're doing +1, so we're going diagonally bottom right, but it should be on J. So it works on, like, it should be J, and maybe we just need to try brute force the different symbols for it. So 7J, so that's that. Maybe we try F, which is like, would F work? I don't know, let's just try it. Let's run this and just see what the different numbered outputs would be. That's 9. Like with this, we know it's J, we just need to figure out which other one it needs to be. So how about L? 7. And what's the other symbol? J. Wait, we did all the other symbols. Well, L gives lower, which it should be. And 7. So we'll keep it on L. Okay, let's try remove just all this stuff. Not all of it. X, Y. Let's run it. Okay, it's now on 13. But let's, if cell equals dot, that's fine. So we got these numbers. Got crosses, which we're now going to be doing that with. I just realised I actually did X and Y backwards. I mean, it works, but technically, these are the Y coordinates for the first index, and then you go through and get the X one, but anyway, that's fine. So while X is within the grid, Y is within the length, that is fine. Okay, actually, we don't need that. Let's go back. What are we using in this one for returning? Red steps. Alright, we changed that to the valid pipe one. Wait a minute, we have it, so it's not in J. We want it to be J. So this should be 7. Oh, do we want this to be 7? Okay, well maybe it's not 7 specifically, but either 7 or F, like, we want it to be J. So let's run that again. Oh, and we got 4. Oh, I can't believe I overlooked that. Like, I knew what it needed to be, but I put 7 in. So let's go get our puzzle input again. We will put that into here, and for the sake of having it run quickly, we will remove part 1 and let's run it. Okay, so that gave us 50. That feels really low. Actually, how many dots are there in here? Oh, it's not giving us a 524. It's possible that it could just be 50. Is it 50? Yep, 50. So let's put 50 in, and hopefully that is all that. Yep, so didn't think so. Didn't tell us whether it was higher or lower though, which is annoying. So what else could be in this? Don't know if it changes anything, but let's do that. So 50. Okay, same result. So that stays the same. Something that we could change. Let's turn this to a set. Valid pipe, where you used, and we'll do valid pipe if xy not in valid pipe dot add xy. Sure, we'll do that. Then valid pipe down here if x2 y2 in valid pipe. Does that change anything? Oh, my bad, that should have been like this. And that doesn't change anything. Okay, so there's one change I made here which has given me a new number. So instead of checking to see if the xy in the grid is equal to dot, I've just done if xy in valid pipe continue. So I don't know if this is going to do anything. I've been trying to find a solution for this, but I don't know. So I'm kind of just trying anything at the moment. So let's see, 491. Is that the... Okay, so that is the correct answer. Why would that be the case though? Because it's possible that outside the valid pipe there's things which... Like, I would have thought there would be situations where it's not within the pipe at all. And then, but does that get counted as a dot or something? Is it just any square that's outside or what? Oh, on this one right here, dot pipe, like these ones are invalid, but those are counted as being inside. Okay, so I would have sold it so much quicker if I knew that. But anyway, that is day 10 of Advent of Code 2023. If you like this video, make sure to like and subscribe so you can watch me try and solve these challenges.